and welcome to Technical Utkranti. In this video, we'll understand the scope and the control flow in C programming language. What can you expect to learn? What are local and global scope? Static keyword with respect to variables and functions. What are register variables? And then in control flow, we'll see goto statement followed by what's coming up in the next video. So let's get started. We learned in the previous video the usage of functions and modular programming. We emphasized on the need of implementing a particular functionality into smaller functions while coding. Modular programming is to use the same module implementing a certain functionality into other .c files of the same project. So let's say if the Fibonacci calculation is implemented in one .c file, then treating it as a module, how can we just reuse the same implementation in other .c files without having to implement it again and again? In this video, we'll see scope of variables and functions. Where a variable and function can be used is called the scope of the variable or the function. We'll see what limits the scope of the function and a variable. Then we'll have a look into the goto statement, which allows us to jump to a particular point in the file, in the function. So we have this particular function being written over here. I have a variable a which is declared outside the function and a variable b which is declared inside the function. Any variable which is declared outside the function, it can be used in all the functions of the same file, and it can also be used in the function of other files if other files are also the part of the same project, which means that if they are compiled together. The only thing is that when you use that variable, you have to declare it as an extern over here for the compilation purpose, and it will take the same value as is over here. So let's see if we can use a over here. So this func is being called over here, and we'll not print this here to avoid complications. Let's see. So as you can see, the value of a being 10 is being printed after happy birthday over here. So this is the global variable for you. And now local variable. So I'll just comment this out over here and print the value of b, and it does not require demonstration, you know it could be done. What is important to understand over here is that if I define this particular variable inside another block, then the b over here will not find its definition because now the scope of the variable b is limited within these blocks. So an important thing to understand is that it is not the function which defines the scope of a variable, it is the block inside which the variables are present which define the scope of the variable. I hope it is clear. Now remove these things and let's move ahead. So functions also have scope, but that we'll see a bit later. Now another concept is to have the variables with the same name but different scope. So I'll have this commented here, and let's suppose that this global variable and local variable have the same name. What will happen here is that this function will print the value of a as is over here. Why is it like that? This is a global variable, and during compile time, this is allocated the memory in the RAM, whereas this is allocated memory in the stack during runtime, and in the function the local variable takes priority over the global variable, and as a result you will see that the value is 5. Yeah, all right. So this is about it. If we have the variable with the same name and same scope, then it will result in error. But if their scopes are different, then functionally it's not a problem to have the same name variable, though it's not recommended for readability purpose. Okay, let's get ahead. Now we'll have a look into the static keyword. The role of static variable is to limit the scope of a variable or function. Let's understand it with the help of an example here. So let's simplify this code for better understanding. Let's see what we are trying to do. Here we are calling this function num of students 3 times. And over here I will not have it declared as static, but for now I'll just have it as a normal variable. Let's see what is printed. I get 1 3 times. But what if I do it as static? What will happen? I have it as incremented every time the function is called. So the usage of static keyword is not only just to limit the scope of the variable, but also to have it declared or defined only once. Only once it will be initialized on the first call of number of students, and then in the subsequent calls, it will take the value what it hold previously. So such uh, static keyword, could be used to keep the count of how many times this particular function is called and things like that, right? This is the usage of the static keyword. A static variable outside the function, like over here, could be used anywhere inside the function. So let's say I just do y plus equal to 1, printf percent %d, and so I can do like this, but I cannot use static variable before having it declared. So if I compile, it will give me an error. So the same rule applies with static function also. If I have this particular function as static, then I will have to have it declared it over here before using it here. When static keyword is used with a variable or a function, then it cannot be used outside the particular file because extern keyword cannot be used with static keyword. So the static variable or function cannot be externed to be used in another file. So I hope static is clear for us. Now moving on to understand the register variables. For a normal variable, which is a global variable, it is assigned the memory in the RAM by the compiler. So when a processor has to access that variable, it has to perform load and store from the RAM, which takes a little bit of time. Register variable is a variable which is allocated directly the register of the CPU. As a result, the time required in loading and storing data from the RAM is saved. But in general practice, the user does not have to consciously name a particular variable as register variable, because the compilers today are smart enough to convert any variable to register variable if it will result in faster computation. The user would not have to do it on his end. Another important thing to remember is that only local variables can be register variables, because global variables are anyways allocated address globally into the RAM. So I hope register variables are also clear. Now let's finally look into the goto statement. Let's suppose I create a label here and I say that if I is equal to 2, go to label 1. What it will do is, where is I? Just at the top to avoid error, and see it will just run infinitely, because at I equal to 2 I am not incrementing, rather I am running over here again. So this will run into the infinite loop. So that is how the jump statement works. Another important thing to remember is that even though label 1 is defined at line 11, I can jump using that label from line 10 itself, which means that label declared anywhere inside the function, but it can be used even before it is declared. The third important point to remember with goto statement is that you cannot jump from one function to another function. Okay, so that is another important thing to remember. Fine. This brings, okay, last point over here is that goto statement usage is generally not recommended, because if you jump from one line to another line and from that line you jump to the line previous to a line where you jumped for the first time. Okay, maybe that sounded a bit confusing, but the moral of the story is that goto statement jumping can produce very complicated code to analyze and debug. Goto statement can be used in error handling. So for example, if printf or scanf gives EOF, end of file, and it has to be treated as an error, then upon reception of EOF, a goto statement could be used to jump to a certain part of the code which is made for error handling. So that is one use case of the goto statement. In the next part of the C programming series, we'll have a look into the input and output with the C programming language. What are input streams of data? What is output stream? What is buffer? All these things would be seen in the next part of the video. Till then, goodbye, and hit like if you've gained anything of value from this video, as your like will motivate me to come up again with more enthusiasm. Thank you. Bye bye.